Parental dosage of drugs. Parental dosage talks about in routes of administration gastrointestinal, other than gastrointestinal, okay? So this is kind of getting a little sciencey on us. We're not going to get that deep in the science part. We're going to actually learn how to solve mathematically. However, it is important that you know what these abbreviations stands for. Intramuscular is IM, subcutaneous is subcut, intradermal is ID, and IV is intravenous. Guys, you need to know more than just the definition or the abbreviation to the actual word. You need to know, what does it mean? Where is it located on the body? What are they talking about? Because the more you learn now, the easier it will be when you're in the program, because in the program you've got so much more other material to learn. So I'm not going to get into the science part, but I'm leaving it up to you to research on your own. Whenever we talk about parental routes, you talk about different syringes, syringe sizes, and we also talk about different gauges on needles. So there's a lot to learn here that's science, and I encourage you to go above and beyond to learn it, to make it easier for you. So that's saying I want to skip through this reading part, the science part of it, and let's go straight to the math. So whenever we do the math part, we can apply this three-step approach. We're going to convert, right? We're going to convert any needed conversions, as well as our order or our patient's weight or recommendations, whatever it may be. We're going to convert it to what we're wanting. What are we looking for? Is it tablets, milliliters, capsules? I mean, what is it we're solving for? Okay. And then we're going to think about it. We're going to make sure that our setup, our conversion setup right here, guys, we want to make sure that it's set up correctly and reduces down to give us what we're actually solving for. And if it's not, then we need to go back and reevaluate it. Step three says we're going to calculate it. We're going to use formula method, or you can use dimensional analysis method. But either way you go about it, we're going to calculate to get what we need, okay? And then I strongly encourage you to take this number 2 and make it a number 4. Step 4, we're going to think about it. Is my answer correct? Does it make sense? Does it really apply to this patient? Is it too much? Is it safe? There's so much to ride here to ride up on this question to make sure that we are doing right by our patient. So let's take this example here. We have an order of 150 milligrams intramuscular, so it's in our muscle, every 12 hours. We want to know how many milliliters, right? How many milliliters will we administer? Because whenever we're talking about injections, it is usually a liquid form, and it's usually measured in milliliters. Now I say usually, I don't want to get into the science part. Again, we're just going to do math. So we have this supply, and it says 300 milligrams per 2 milliliters, and we're solving for milliliter. So what we want to do is we want to look at this unit on our order and check it with the unit on our supply. And if they're equivalent to each other, milligrams and milligrams, yeah. So we don't need a needed conversion. If they weren't, then we would. So let's take our order, which is 150 milligrams. Write it over my half, which is this 300 milligrams. And we're going to multiply it by our quantity, which is 2 milliliters. And I'm going to use approximation sign. It's not really a good one, but anyways. Now I'm going to come through, I'm going to say milligrams, reduce with milligrams. And we know that 150 will go into 300 2 times, right? So that leaves me with 2 on bottom. How do I write it? I say 150 goes into itself once, goes into 300 2 times. So now I have 1 times this 2 milliliters over 2. And 2 goes into 2 1 time and leaves me with 1 milliliter. So that is my answer. So again, we applied the convert, and then we thought about it. We set up the conversion. When we thought about it, we realized that the units in the order and the supply are, they're both the same, so we can reduce the unit out. The numbers are not, the amount of them is not the same, but the milligrams were reduced with milligrams. And once we solved it and we got 1 milliliter, we're going to compare to make sure it sounds safe. Since it's 1 milliliter, we will definitely want to use a 3 mil. Don't get me wrong, the science of it, you can use a 1 mil syringe as well, but you have to use whatever you have supplied. It says that if you was to graph it, as you notice that the 1 mil mark ran right here on this little corner right here, guys. That's because the fluid goes there, and it goes from here to there. So in this class, I love for y'all to be able to shade, but we don't get to meet in person, so I have to figure out a way for this to happen. So make sure your shading is correct. You understand it. You know that the medicine doesn't go into this part here as well. So let's skip over to an example. So I have an order, and it's in micrograms. I have a supply, and it's in milligrams. Oh, what do I know? We need a needed conversion. What are we solving for? We're solving for milliliters, right? If you go ask, usually I'll have a question with it. So we're going to need a needed conversion. So I'm going to make my statement that I know my needed conversion is 1 milligram is equivalent to 1,000 micrograms. Now, once I've made my statement, I'm going to come over here and set it up. I'm going to take my order. And I'm going to use dimensional analysis, but if you want to use formula method, that is fine with me. I'm going to use dimensional analysis because I like to have it all in one long row. But if you want to do it in parts, that is fine too. You can say 150 divided by this 1,000, which will give it to you in grams, right? And then you can use that. It's up to you. But I like to do dimensional analysis because I can set it all up. So I have my order here. Now, this next part could be the available, the supply, or the needed conversion. And the reason why I say that is it's multiplication. So in multiplication, if I said, what is 3 times 2? Y'all will say 6. If I said, what's 2 times 3? You'll still say 6. So this is why it doesn't matter if the needed goes first or the supply or the available. And it's usually up to the person. A lot of times it's easier to go with the needed next. Why is that? It's because you see the micrograms on top. That means it has to be on bottom on the needed. And it might actually help you set it up correctly. Right? So here's my needed. But another thing, though, if you was to plug in the supply, or you can call it the available, let me erase that. It looks like a 5. This is why I don't like y'all using S's in here. The supply, we know whatever we're solving for goes on top, right? But sometimes you're in a hurry and you tend to overlook what you're solving for. And if you set it up this way, now we can go through there and go, oh, micrograms reduce micrograms, milligrams reduce milligrams. What I want's on top. We're good. So next, I can say 150 times 1 milliliter. All over 1 times 1,000 times 2, or 0.2. So 0.2 times 1,000 means we're going to take the decimal and go this direction 3 times. So it's going to go 1, 2, 3. So it gives me 200. Right? So we go 1, 2, 3. Okay. So now let's reduce. We know that 150 divided by 200 doesn't give us a exactly clean number, but it does give us what I call a clean fraction. It's actually 0 0.75 milliliters. Okay, so in this section, we will round to the nearest hundredths. However, here's the thing. If we are using a 3 mil syringe, right, versus a 1 mil, that will determine our rounding. Our rounding may be different based upon the supply given. So make sure that you can say, look at the supply given. If you were given a 3 mil versus a 1 mil, look at their units. How far out do they go? Do they measure round to the tenths or the hundredths? And that will determine on how you round here as well. For this class here, unless I specifically specify on the rounding, we're just going to round to the nearest hundredths, okay? So on this section. So this here just shows you how to work it. Let me see if we have another example right quick. And this here actually talks about the syringes, guys, and when to round on which ones. So definitely read up on it. It would not hurt you to already know this. And then this one talked about insulin. It's measured in units, and its unit is actually a U, and the abbreviation is U. So here we would have called it a capital U. And it says that you can have, for every 1 milliliter, you can have 100 units. That's what this means. For every 500 units, you have 1 mil. This is what this means. So whenever you're given a specific order and you see the capital U dash 300, that means it's 300 units per milliliter. It can also be written as 100 units, 100 capital U. So just make sure you understand the reading. I got some pictures of syringes and explanations of it, so it's definitely a plus for you to read it and get to know it a little bit better for when you get in the program. This one here says when we have insulin, sometimes insulin has 2 different types of hormones mixed in, and we got to give it an injection. So if you had 40 units of the NPH, we're going to draw it up, and then you have the 12 units of the regular, and you'll draw it up. Those 2 added together gives me 52. It's 52 total units that you're going to administer. How you mix it up is determined on the science part. How much is what the math does. So these here just explains to you how to mix it. Moving on. So say we have an order of 100 insulin, 100 units of insulin. This here, again, it means that we have 100 units per milliliter. That's what that means. For every 1 milliliter, there's 100 units. So I want to know, we're going to do it sub-Q based on glucose reading at 1600, right? And I thought this was a question. So let's make a question up. I want to know, say this is what we have as an order and what we got supplied to us. Let's just say we got a supply of 500 milliliter or 500 units. And we want to know how much we're going to administer. So I'm getting a little deeper into this. This is just the basic math. What if I said 500? That means I'm just going to take that 100 divided by 5. That's going to give me milliliters, right? It's going to be 1/5. Again, we don't want to leave it in fraction form. And this is just, guys, this is not, it'll be more specific when you do this, okay? I'm just kind of giving you a feel for it. So, again, please read this chapter, get familiar with it, and ask your instructor questions when you have them. Thank you.